Hi, everyone. Welcome to the webinar. This is Approaches and Challenges to Migrate Hadoop Data to Azure Data Services. This is the fourth installment of our webinar series. This is also the last webinar. However, if you did miss any of the previous ones, feel free to go onto our website, www.motiveworks.com, and you can watch all of the webinars up to this one. Our presenter today is Tarun Agrawal. He is our data and AI lead at MotiveWorks. We are very lucky to have him presenting with us today because he is incredibly knowledgeable, and we're really lucky to be able to sort of pick his brain on all of this knowledge and all of this information. So without further ado, Tarun, I'm going to go ahead and turn it over to you.
Thank you, Sarah. Thanks a lot. Thanks for the introduction. And hello, everyone. Good morning, good afternoon, good evening, depending on wherever you're joining it by this webinar today. Thanks a lot for taking time away from your busy schedules and joining this webinar. I hope you will be able to get something productive out of it today. And we are always willing to and happy to hear from you. Please do share your feedback about how do you like the webinar or anything else you would like to see in future. So with that, let's jump into the webinar for today, which is around the approaches and challenges that we have when we try to migrate our Hadoop data into Azure data services. Before that, quick background about myself. Myself is the director of the data and AI practice for MotiveWorks, and we help modernize data platform to use it to use the data as a strategic asset for the organization. We try to use the data to enable a data culture and drive data-driven decision making for the organization. We do it by building data platforms in cloud and using Azure cloud services, as well as in leveraging machine learning, artificial intelligence, and big data to drive the businesses forward. And prior to MotiveWorks, I have experience building data platforms into large Fortune 100 to Fortune 500 companies prior to joining MotiveWorks. And I'm always working with my clients to have a client-first approach and to help them drive value from their data. Slight background about MotiveWorks. MotiveWorks is a company which is headquartered in Maryland, right outside Baltimore. We are a company which is born in cloud, and we always have a cloud-first approach. We are Microsoft Go partners, and if I take your attention towards the bottom right of the screen, we have acquired all the right credentials to be a trusted partner with Microsoft, and we take pride in working with our customers who are trying to leverage Microsoft Cloud Platform to adopt the cloud, whether they are looking to move into cloud in a rehost or re-platform or re-architecture kind of approach, and then use the cloud platform to build cloud native applications using microservices, containers, and other services of cloud, and build a connected ecosystem of the next generation applications. And we also leverage data and AI to drive the digital transformation by building modern data platforms, enabling cloud scale analytics, big data analytics, and leveraging machine learning and AI to drive the businesses using data. So with that, like we mentioned, we started this series of 4 webinars around doing big data analytics in Azure cloud, and how do we really try to deliver ROI on the big data investment that customers have made by leveraging the cloud platform. Today is the 4th one. I hope you were able to attend the prior 3 ones and able to get something out of it. And if for whatever reasons, if you have missed the 3 prior ones or any of them, you can always register on our website to watch the recording. All right, so the agenda for today's webinar is going to be looking at all the approaches and challenges. First of all, just to understand and acknowledge the challenges that we have of running a Hadoop environment on premises, and why cloud becomes the future, and why we should be migrating into the cloud, all the Hadoop workloads. And then let's also acknowledge and understand the complexity of migrating a system like Hadoop into cloud. and what are the different approaches we can take to reduce the complexity and really have a successful migration. So with that, let's jump ahead into our presentation for today. So today, Hadoop platforms for running big data workloads on premises are becoming more like an IT debt. Why do I say that? Because just talking to many of our customers and looking at how they are leveraging the Hadoop platform, about 40 to 50%, and in some cases up to 80% of their resource bandwidth, the IT resources they have to support the Hadoop platform, just goes in managing and maintaining the server, the Hadoop servers, and keeping the lights on. The cost of platform is rising. We always have to build Hadoop platforms for peak capacity. We have to estimate and approximate the capacity need for the peak workload ahead of time, make substantial investment in adding as many nodes to the Hadoop cluster, and constant management of maintenance, upgrade, backups, job failure just takes a lot of bandwidth from the resources and does not drive the agility, the business agility that the business is trying to look by having all this investment and trying to drive their businesses. It takes a long time to add a new use case into current Hadoop environment. And it also lacks innovation. If you want to do machine learning or artificial intelligence, and it's possible, but it lacks not full, does not have all the capacities and capabilities. It lacks full capabilities of what you would require to run machine learning kind of algorithms on in your environment, and it creates data silos of probably creating a separate environment to enable machine learning kind of a use case. So we have looked this in the past. So just to refresh, what are some of the challenges we are talking about? So the idea of moving away from data warehouse kind of technology for doing business intelligence and reporting into data lake kind of a solution was the right approach, and it had a lot of promises that we can collect all the data, we can store all the data, and we can analyze all the data. That's really the promise of data lake, and that's the right way if you are really trying to use data to drive your businesses. But then the Hadoop data lake solution brought some challenges. When we are trying to append the data into the data lake and users are trying to read, they do not get, because it's miss the atomicity. It will miss and have dirty reads. When you're trying to modify the data in Hadoop data lakes and trying to do update or deletion kind of data modifications, it's very, very difficult to manage that into a Hadoop environment. And if whenever job fails, and there are thousands and thousands of workload runs, and whenever job fails in between, to clean the data to come back to a consistent state is very, very difficult today. And this kind of infrastructure cannot handle the data coming from a batch mode as well as a streaming or a real-time mode into one single view, and that becomes a challenging. And as we keep on bringing more and more data into Hadoop environment, and we keep on adding data into incremental files, so over a period of time, the throughput and the performance of the system goes down because of having a lot of small size files into the environment. And by definition, data lake needs small files because you are going to add more and more data into it, and it's going to continue to grow as this incrementally, and we will continue to keep and adding small files. So there should be a better solution of managing all those things to really make the promise of data lake really come to fruition. So how do we do that? In today's Hadoop environment, it's not possible. That's where the cloud brings the agility and innovation. You do not have to guesstimate or estimate your workloads ahead of time. You can scale the resources in cloud with a click of few buttons, whether you want to scale up or scale down. It gives you the speed that is required to process these workloads and to deliver the business value and agility by having on-demand processing power and optimize resources for compute by decoupling compute and storage. So you are only paying for what you need. That's how it's able to generate the cost effectiveness. You just pay for what you are consuming, and you do not have to pay for buying large investment of acquiring all this hardware. And we also talked about how can we build a unified cloud data platform that looks at data holistically by bringing all the data, whether it is structured, unstructured, batch, real time, whatever the use case may be. We can bring the data into Azure Data Lake Store. That becomes your de facto data lake when we talk about collecting all the data and storing all the data. That becomes your layer. And then to analyze and to overcome all the problems that we have seen in a typical Hadoop data lake can be overcome by implementing a structured transaction layer on top of that Azure Data Lake Store that gives you the asset transaction layer, which gives you the atomicity of between the transactions. It gives you the consistency of the transaction. It will keep the isolation level intact, and it will be durable. So that's the structured transaction layer, like a typical relational databases present this kind of ACID technology in all our databases that we have been using for last 20, 30, 40 years. It becomes to life using Azure Databricks Delta Lake technology. We can use Delta Lake in Databricks to build that structured layer on top of our Data Lake store, and able to overcome all the problems that we have seen in a typical Hadoop on-premises environment. And from there, we can build our warehouses, whatever, depending on the use case we have, on the size we have, and leverage Azure Synapse Analytics to bring the MPP scale power to in the cloud. And we can use the same data available in our data lake store to analyze either machine learning use case, artificial intelligence, cognitive service kind of use cases, or if we are looking for ad hoc interactive reporting, dashboarding kind of solution, we can use Power BI. So using this kind of a unified cloud data platform, it gives you all your reporting, analysis, business intelligence, data science, all the different kind of use cases can be supported by building a solution like this and overcome the problems that were caused by traditional data lakes, and also becomes on-demand scalability, cost effectiveness, and agility to build this platform. How do we leverage this platform when we're trying to move Hadoop environment into Azure? So if you look at Cloudera distribution or even a Hortonworks distribution, there are more than 24 services available there. Since I think Cloudera probably has close to 30, 40 services available. And a lot of customers end up using a lot of those services. So this is a sample mapping of what services from Hadoop can be ported into what services in Azure. Your data lake store, which is in HDFS, will come to Azure Data Lake Store. All your workloads, whether it is MapReduce or Spark or Spark SQL kind of workloads, will move into Databricks. Your data lake store, like in Hive, the Hive meta store will come into Data Lake. And your streaming kind of use case, that probably if you are using Kafka publisher subscriber model, that can translate into the Azure Event Hub PubSub model, and you can have the streaming subscriptions enabled. If you are running a NoSQL database in HBase kind of technology, that will port over to Cosmos DB. And if you are building warehouses using Impala kind of technology, it will come into a Synapse Analytics. And other thing, we can also have permissions ported over the orchestration of the jobs of the workloads, which currently we might be using Uzi, or some people use Airflow. They all can come into Azure using Airflow DAG and the Databricks job combination. So that's a sample representation of how you can migrate your existing Hadoop workload into Azure. But it's typically what we have seen is Hadoop environments are monolithic environments. It has a lot of footprint and large footprint, and the migration of all the services we just have seen in the last slide into Azure is going to be a complex migration. There's no magic wand available in the market today that can move this environment and the data and the workload with the flip of a button. It will require some hard work, and that's really, we need to look at it holistically, that what are some of the challenges we will face and how to really plan for that migration, so that the complexity of migrating hundreds of nodes, the data, probably we are talking about in a typical footprint, we are talking about terabytes and petabytes of data in Hadoop data lakes, right? We are not talking about small size of data, MBs or GBs. So how do we migrate all this data? How do we migrate the workloads, whether it is your Hive jobs or Scoop jobs or Azure Spark jobs, which are running, which could be in thousands, depending on number of use cases you are running, into Hadoop. So it requires a lot of strategy and planning to really think about migration before you actually start into execution. So these are the components that you require for a successful migration of your Hadoop workloads into Azure. And in our experience working with our clients, we have seen that unless we have a well-defined information strategy in place, it's probably not going to be a successful migration and able to deliver the ROI that we originally think we are going to get out of this migration. First and foremost, it has to have executive buy-in, all from the C-level stakeholders. They should have a mandate to migrate into cloud and use Azure, in this case, Azure Cloud Platform as a strategic platform. Without that, if we try to migrate at our individual team level migration, it's probably not going to go too far. We need to identify how this migration is going to help the business case. What are the business drivers and business outcomes business is trying to achieve? And based on that, we have to identify very clearly those things so we can build the environment to achieve those business cases. We need to implement a solid foundation of cloud, whether what is going to be the identity management, the network strategy, the access management, how are we going to govern it, what roles business people are going to play, how are we going to manage and govern the cost, how IT projects are going to be started. So a lot of governance and needs to be in place, which we help our customers using a cloud adoption framework. Without that, which is a lot more to do with change management than anything else. Without this governance, we have seen that the impact of the cloud migration may not be as impactful or efficient as originally anticipated, because we did not really think about managing and governing the cloud adoption program. We need to have a very well-defined strategy and roadmap. Which use cases are running in current Hadoop environment? Which of them will be candidates for migration? How are we going to prioritize them? Which is going to be giving high value, and which of those are more complicated that can take longer time? So we need to have an understanding of all those things and come up with a strategy, and then come up with the execution blueprint of wave-based migration. We cannot probably migrate everything in one go. We need to prioritize the use cases, prioritize the data based on the use case that are being prioritized, and then build a blueprint of wave-based migration, and then start mobilizing the teams. So without a proper strategy of looking at a Hadoop migration project, it probably will not be as successful as you originally thought it will be. So these are some of the components to keep in mind. And along with that comes the partner selection. Typically, to do this kind of a migration, you will require some partner who's going to help you go through this journey. And what are some of the key things you need to look at when you go for a partner selection? Is, do they have a clear methodology? Do they understand what does it take to build that cloud governance framework that I was talking about, and build a change management strategy, identify the prioritized workload, come up with a wave-based migration plan? Do they have expertise? Do their leaders have the right expertise of engaging with executive leaders to think about how to prioritize the use case? Do their developers and the doers, the data engineers and data scientists, have the expertise? Do they have the right credentials? Do they have the experience and success stories where they have done it in the past with other customers, and can they customers vouch for them, and can they be trusted? Can they work as a trusted advisor to help clients achieve this migration journey and bring to life? So some of the things are very, very important when you're going for partner selection. And let me talk about how Motiveworks look at this migration of doing Hadoop migration to Azure. Like I mentioned, we require a strategy and roadmap and an execution plan. That's what we try to help our customers achieve. We start with the business value workshop by engaging with the senior stakeholders, the business from the business side as well as technology side, to really understand their current state, understand the use cases that they are running in Hadoop, and then designing the reference architecture of what would it take to move it, and help them build a business case and a total cost of ownership of running this platform in Azure. So that's gonna drive, I think, get the executive buy-in once we do that. And then do the assessment of their current environment, look at what inventory they are running, right size it so that we understand exactly what would it take when the environment is going to move into Azure, how much consumption it will take, and what dependencies and what some of the challenges we will face, and based on that come up with a wave-based migration plan. And then first, instead of doing a big bang, first do an MVP deployment, identify the top prioritized use cases, build the right landing zone, deploy the right services, build the network strategy, the identification management, Active Directory, and other things which is required for identity and access management, and then deploy the use case, the prioritized use case. It depending on what the use case in your company, the use case may be. In a retail company, it could be market basket analysis or customer segmentation, and then migrate the data which is needed, which is there in HDFS to support that use case or use cases. And once that is successful, people are able to use it in Azure platform. Everybody is happy with the performance, the output and the ROI from this use case. Then start to deploy the remaining use cases and for a full implementation, and extend the MVP beyond to go for full implementation, implement automation, alerting, management of the resources, those kind of things, and to really have a full cutover from Hadoop environment. So these are some of the outputs that we will be able to deliver when we will conduct business value workshop, identify the business case and the total cost of ownership. Then we will come up with a reference architecture. We will do the MVP deployment and then do a full implementation where it gives you a unified environment platform that as we have been talking about. How do we conduct business value workshop is we do a discovery, and then we have a strategy workshop where we identify your North Star. That what exactly are we trying to achieve, what the business drivers are and the business objectives we are trying to achieve, what the prioritized use cases are, and what the business case and the total cost of ownership is going to look like. So that's the output of business value workshop. This is an example of the use cases of Hadoop prioritization, based on looking at each use case from a business value perspective, how high of the business value it provides, and what is the level of effort and what is the feasibility level of achieving in Azure Cloud Platform when we do this migration. And based on that, looking at the high business value and high level of effort, we identify some MVP use cases that will be used to deploy as MVP, and then also use this to come up with a wave-based migration plan. So this is the example of a business case that we can help you achieve, that currently in your Hadoop environment, how much is the cost of ownership you have based on the nodes, the data, all the services that you're using, the licensing cost, the hardware and software cost of ownership, and then what would it take to move this environment into Azure, what different services and how is going to be used, how the compute and storage is going to come, what would it cost you, and how much savings you can expect by migrating this from Hadoop to Azure platform. So this is a sample of that. We help you define the value map, as I talked about in the part of workshop, that based on all the things that you are leveraging in Hadoop and the different use cases, what kind of ROI you can expect by migrating this effort, and then it's having an investment for the migration. How that investment, how much ROI it can generate to you, and what's the payback period is going to be, how much cost saving it will generate, what is the productivity increase and the revenue growth it can bring to your company. This is an example of a reference architecture. What would it take to move your existing environment into Azure, and what the Azure services and reference architecture is going to look like. This is how we will give you a complexity versus effort analysis of your different various workloads running in your on-premises environment, and identify the hardware which is supporting each of the use case, and what is the complexity and of that of each of the workload is, and how much is effort it will take to migrate. Based on that, this will be input into the wave-based migration plan, which will give you multiple waves, and each wave, which workload, which hardware, which servers, which storage is gonna go and move into Azure. And by doing that, we will be able to build you a unified big data analytics environment where the data engineers, data scientists, data analysts, everybody can work together in a unified environment, leverage unified data, unified services, and does not create any data silos. You do not need a separate environment to do machine learning versus running your data lake or NoSQL databases. They all will be unified by building this environment in Azure. That's really the output and the final end goal we are looking to achieve by doing this migration. So we talked about approaches of doing the migration. What is it needed to identify and select the right partner? Let's talk about some of the challenges that you can face when you move the Hadoop data. And as I was talking about, when we are talking about Hadoop environments, we are talking about data in terabytes and petabytes. We are not talking about MBs and GBs data here, right? So it's a large size data. It is running on possibly multiple Hadoop nodes. In some customers, we have seen over 100 nodes and 200, 500 plus nodes are running in Hadoop environment. In some cases, we are talking about 30, 40, 50 nodes, but still it is a large size environment which is used by hundreds of users, multiple users, and a lot of workloads are continuously running. So data is constantly changing into the environment. So how do we move this data into Azure? And data migration, it is a simple math and a science. There is no magic involved. To give you a data point, if you're trying to migrate 100 terabytes of data, it will be, you need effort to migrate that 100 terabytes from one place to another, from your on-premises to cloud, right? So it really depends on two factors. How much is storage? What is the size of the data you're trying to migrate? And what is the network bandwidth you have available, right? There's nothing else. Yeah, you can optimize by maybe use compression to reduce the size, but at the end of the day, the size of the data that you're moving across network and the network throughput you have available is going to give you the time it takes, the simple math. So give you an example, if you're trying to move 100 terabytes of data using 100 Mbps network bandwidth, 100 megabits per second, it's going to take you 97 days. That's a simple math. But if you're able to increase the network bandwidth from 100 Mbps to say 1 GB per second, so 10 times, the 97 days is going to cut down to 9.7 days. It's a simple math. Yeah, we can reduce the size of 100 GB by 100 terabytes by compression. That's a different thing, but amount of time it takes to move the data is dependent on the size and the network bandwidth. If you're able to increase the bandwidth from 1 Gbps to, let's say, 10 Gbps, it will cut down to 1 day. From 9.7 day, it will cut down to one day. But it all depends on how much network bandwidth you have available. And a lot of time, there are other users using the same network bandwidth for other things that they are doing. So you may not have full network bandwidth available to migrate the data. So we have to identify how much is available for the migration purposes. Is it 50%? Is it 100%? I do not know, depending on the environment. That's what we have to see. And second thing is that we do not have always the same throughput and on the same bandwidth available. It keeps getting spikes up and down. So keeping all that things in mind, that's the amount of data time it's going to take. And during that time, we are not going to stop and shut down the business. People will continue to use it. If we only have 100 Mbps bandwidth, and if we have to move 100 terabytes data, nobody's going to wait for 97 days. Business is going to stop. This is not going to stop for 97 days. So how do we manage migration when the data is constantly changing, when business is still using and does not cause any disruptions, right? How do we maintain and manage the consistency of the data? As we are moving, migrating the data is constantly changing. Maybe the migration fails and we have to restart. How do we keep it consistent? How do we ensure that my data is fully intact and everything I see on my Hadoop side is already there in my Azure side, right? How do we prevent data loss? How do we factor in for high cost of migration? I mean, if you have to run this migration for 97 days, you can imagine the cost of doing this migration, right? It's going to be high cost. And how do we secure this data? How do we make sure that everything, all the securities and permissions which is there on HDFS side are in place on the Azure side? So the people who are going to start using in Azure going forward, they still have the same permissions and access rights to use this data. So these are some of the challenges that we have to think about when we talk about migration of HDFS data. So what are options we have available? How do we actually migrate this data? So there are multiple ways we can look at migration. One of the most straightforward that a lot of people use is write custom scripts. So there are different commands available. You can use those commands to write custom scripts and then start executing those scripts to migrate the data. It's going to be time consuming because these are custom scripts written for your environment by the people who are working for you. So amount of time it takes to write those scripts is also going to be a big factor. But when we talk about migration of and moving of large data from on-premises environment to Azure, Azure also provides a data box kind of a fun feature, which is basically a piece of hardware coming to your data center, and you essentially put all your data into this hardware piece of hardware, and you put it into a UPS or FedEx truck. It goes to Azure. Azure is going to take it and dump it into the data lake store. So it goes into Azure, right? So you can do that way. But then amount of time it takes for you to load the data into this box, and then the amount of time it takes to ship it to Azure data centers and then make it available probably takes 2 weeks or so, right? So how do we do that? What do we do once the data is there? Now 2 days or 2 weeks old, if that is the case, the amount of time it took. So that's when we will have a hybrid solution that you send big chunk of data through Databox, and then you do a catch upload so that you can now catch up for that 2 weeks of gap that you have in Databox data. Or you can use ISV tools, and there are many tools out there which help you migrate the data. And it can do automated, it can do uninterrupted, it can do even the catch-ups are possible. It can identify the delta. That's another option. So there are multiple options depending on what individual customers' priorities are. We can choose any of these options to migrate the data. But the basic fact of amount of time it takes to migrate across the network, if you are using the scripting or ISV tool, that still stays the same. And there are ways to optimize so that you get better throughput, minimize the size of the footprint you have to migrate, so that you can achieve that zero disruption, zero downtime, zero data loss. So that brings me to that business continuity I was talking about. We have to make sure that whatever we do, whether we write our own custom scripts, we use some ISV tools, or we come up with a hybrid approach. It's even hybrid is possible. We have to continue the business. Business should not come to a stop. So we need to achieve zero downtime. So if and zero data loss and consistent data, that's really the business priority. That whatever you guys have to do, you do your thing. But I want to make sure that I'm able to use the environment, whether I'm using Hadoop environment or I'm using Azure environment. I do not care, but I should be able to use it for my work, and I should get consistent data, and I should not have any data loss. That's the we have to make sure that whatever approach we take, we are able to meet these business objectives. All right, so that brings to my poll question for today. So Sarah, if you can bring up the poll on people's machines, screens. Let's take a look and try to understand where do people on the webinar today see they need the most help.
I'm going to give it just a few more seconds. I'm seeing some results trickling in still. So what I'm seeing is that most people are struggling with building a data lake and building machine learning.
Okay, good to know. They need to build data lake. Okay, thank you. Thanks, Sarah, for that. All right, so moving along, just to summarize, I think we are coming to a conclusion of our webinar for today. Just to summarize that what we have learned and observed in today's webinar is on-premises Hadoop environment is becoming an impediment to the business growth. The amount of time it takes to get the use case up and running is just not acceptable to the business to drive the growth that they're looking from IT investments. Azure Data Services, by leveraging Azure Cloud Platform, the cloud native services, platform as a service offers, in some cases serverless offers, provides the agility and the scale at optimized cost. So you can get the better performance and scale on demand, and at a only pay for what you use, and you will get an optimized cost for running your workloads in Azure. Hadoop migration projects are complex projects. It is we are trying to migrate a monolithic environment with a large footprint, and it requires a robust strategy before we actually start execution and mobilizing the team of to just start migrating my data. That's not gonna be successful. Whatever partner you end up choosing, you need to make sure that it's a right partner who have right credentials, their team has right expertise, and they have experience and success stories to back their expertise with real use case studies. Hadoop data HDFS migration, the actual data migration is going to be challenging, and it will be basically capped by the network bandwidth and the size of the data you are trying to move. So you need to come up with the right strategy, choose the right approach to migrate the data, so it gives you the business continuity with the zero data loss, zero disruption, and consistent data. And that's going to minimize the downtime. So that's really the summary of today's webinar, just to give you a peek into what some of the MotiveWorks solutions are there to help you with this journey. So we have our own Hadoop migration offers and practices. We have our own proprietary approaches and methodology to help you migrate from Azure or Hadoop into Azure. So you can certainly talk to us if you need any help. If you're looking to do Databricks implementation, we have accelerated solution that achieves you 10x to 20x performance on your existing workloads in on-premises and give you optimized cost and better performance. So you can talk to us for that. If you're looking to migrate your existing analytical workload, whether they are running into data warehouse, business intelligence, any kind of solutions that you are running, ETL solutions, we can help them migrate into Azure Cloud and enable better performance at cheaper price and really give you the agility and scale of that cloud brings to the table. And along with this, we also have an offer that if you're looking to move the data, HDFS data, we can help you move. We can come and do the technical assessment for you, and we can even move up to 25 terabytes of data free of cost if you're looking to move 100 terabyte plus data into Azure. So you can avail the offer as we are presenting as a part of this webinar series to use. Then if you're trying to come up with a high level cost on your own just to see how much savings you can estimate before you even go for these workshops with us, we have a savings calculator on our website. You can try to plug in just some few data points on your current environment, and it's going to give you a high level cost of savings that you can achieve. Again, this is based on not the actual workload. This is based on high level data points like number of nodes, number of workloads that you're running to achieve. And that brings to end of this webinar series. Today was the fourth one. We have completed all 4 of them. I hope you were able to get something out of these webinar series, and you were able to learn something. And we will open it up for Q&A at this point. And like I mentioned, I love to hear from any feedback you have from you. My email address is given here. Or if you have any other needs you want to discuss about any other thing or a suggestion for any future webinars, please feel free to drop me an email and we'll certainly be able to help you. So I hand it over back to Sarah to see if there are any Q&A questions coming that we can take.
Thank you, Tarun. So right now, everyone, we are going to open it up for Q&A, as Tarun mentioned. There is a little chat box on your screen. You can just type your questions into that chat box, and I will read them to Tarun, and he will answer them. That way, everyone can sort of hear the questions and the answers. If you think of questions at a later date, you can email them to Tarun at his email address listed, and he will get back to you within a day. So, you know, whichever you want to do. But for right now, feel free to type in any questions that you have in your chat box. Okay, we have one question. It says, how do you identify the Azure resource sizing?
How do we identify Azure resource sizing? Okay, so one good thing about Azure is, like I think I mentioned it in the earlier part, you do not need to guesstimate or estimate. If you just want to get started, most of the services we talked about are platform as a service. You can just start with the initial size, and you can increase as you need maybe. You do not have to sit and figure out the right sizing from the day one. But if you are working with experienced people or experienced partners like Motiveworks, we can help you right size the environment by looking at your current workloads, current infrastructure, and give you the right size of what it should be from the beginning in Azure environment. Thank you for the question.
Thank you, Tarun. We have another question as well. It says, how would HBase migrate to Azure?
Okay, so HBase is a NoSQL database running in Hadoop platform, you know, whether it's that you're using on premises. When you try to migrate that into Azure, it will migrate into Azure's NoSQL offer, which is going to be Cosmos DB. So it is not going to be a lift and shift migration. We will have to migrate HBase workloads into Cosmos DB, but that's going to give you the NoSQL database with the low latency and higher throughput than you currently have today.
Thank you, Tarun. Next question. Do we need both Databricks and Synapse Analytics?
Do we need both Databricks and Synapse? Thank you for the question. Great question. Again, yep, Databricks is going to give you that structured layer on top of your data lake store that is sitting in Azure Data Lake. So you need to process the data which is sitting and then really make it ACID compliant is what you need Databricks for. Synapse Analytics is a cloud data warehouse. It's an MPP warehouse. You will need it to run your reporting, dashboarding, analytical workloads. So typically what you do is you process the data in Databricks and then copy the final data that is aggregated and certified for business along with all the business reference data into Synapse and then use it. However, Synapse also now provides its own Spark engine. You can do the same thing that you're trying to do in Synapse. The difference that when you need one versus other or when you need both depends on what kind of workloads you're trying to do. The one big difference that's there in Databricks versus Synapse Spark is Synapse is using open source Spark technology, whereas Databricks has proprietary optimized Spark workload and the Spark runtime and the Delta Lake technology, which you will not be able to achieve in Synapse. So in most use cases, you will probably need both if you are trying to run data warehouse as well. Otherwise, you can also be fine with one versus the other.
Thank you, Tarun. And then we have another question. How long does the HDFS migration take?
So I think I tried to answer this question by giving an example of a 100 terabyte workload. So again, the short answer is it depends on the size of the data you're trying to migrate from HDFS and your network bandwidth. That's how you will identify and estimate the time it will take to migrate. I think I was able to answer this question also in more detail in the beginning.
So we are getting kind of close to the end. I know we're supposed to end at 12:45. So if you guys have any other questions, please feel free to email them to Tarun at the email address listed. I wanted to thank all of you for registering and attending the webinar, this entire series actually. We really hope to see you at more webinars coming up in the future. We actually are planning one coming up in October, so keep an eye out for all of the details on that. It will be more about sort of Hadoop and all of that. So at this point, thank you so much, Tarun, for participating and sharing all of your knowledge with us. We really appreciate having you. And I look forward to seeing all of you attendees at the next webinar. Thank you.
Thank you, Sarah. Thanks for being a wonderful host.